Hello, I'm Ahmed Fawaz. I am a PhD student with TCIPG. I am going to present the work I did during my summer internship at Schweizer Engineering Laboratories. The work involves using Watchdog and implementing response and recovery within Watchdog. So first of all, response and recovery engine is our TCIPG activity where we build automatic intrusion tolerance approaches in order to basically recover from attacks and respond to attacks. We have demoed RRE twice during the past 2 years, and this is the third time we're gonna basically add RRE into Watchdog and add software-defined networking responses into RRE. As for Watchdog, Watchdog is an SEL effort to implement an all-firewall or all-layer firewall. This firewall will implement application layer security policies and network-based access control. So in a traditional architecture, you have all the protective relays connecting to each other and implementing protection algorithms over Ethernet. These devices will be connected using switches, and basically will run protocols such as DMP3, Modbus, and other protocols. Basically, the problem with these protocols is that they're not authenticated or encrypted. So anybody, if they have network access, could inject packets into the network. And this is the problem we're trying to solve. So basically, with engineering access, engineers could connect to these networks using a laptop and do diagnostic work. But if this laptop was connected to a home internet network, then these laptops could be compromised, and then they could send malicious DMP3 packets, for example, that would trip a breaker. So Watchdog is gonna take these packets and look for any malicious packets based on the security policy that's implemented. And basically these alerts are gonna come into administrators who are manually gonna sift through them to look for any abnormal behavior and then manually respond by revoking access. The goal of adding RRE into this project is to make sure that we can automatically fuse the alerts and automatically respond. And basically this is how Watchdog would work. It would work by whitelisting application layer traffic and implementing access control using software-defined networking. So Watchdog is a project which is not a commercial product yet, but the whole idea is that it would have an open flow processor and a microprocessor with Snort implemented, and whenever OpenFlow finds a possibly malicious packet, it would forward it to Snort for deep packet inspection. Since Watchdog is not implemented yet, we are emulating its function by replacing the 2 cores with 2 machines. So basically we're going to have an OpenFlow switch and a host processor, and packets are going to come in and out using Ethernet. And basically OpenFlow will redirect traffic to Snort. Snort is going to inspect them using the policies we have, such as cold restarts are not authorized and direct operates are not authorized. And then whenever something violates this policy, it's going to alert, and RRE is going to take these alerts and figure out a response and implement the response using OpenFlow and send this floodlight and send this flow to floodlight to implement it. And this is basically RRE. RRE is the system we're implementing in TCIPG, and it models the user system and the attack model, and it has an RRE agent model and safety bounds. All of these models are basically put in the RRE agents, and RRE agents would take in the monitoring data, fuse them, figure out what's going on, and based on the cost model of responses, select the best response. When selecting the best response and implementing it, this response could be an OpenFlow response, it could be a firewall change, or any kind of actuators in the network. In the first scenario in our demo, we're gonna try to see the effect of a compromised laptop in a substation. So in our substation, we have a managed switch which connects to a protective relay and an RTAC. And then the engineer would come in with their laptop to use it, and the malicious software would inject a bad packet. So in our scenario, the bad packet is going to be a breaker disconnect packet, and we can see in our box the client will start and it's polling the network, and then if we interrupt it and send our disconnect packet, our light bulb just disconnected. And so this would map to something like a blackout happened. So in this scenario, the regular switch couldn't have enforced the fact that we don't want such a packet to be in. So in the second scenario, we're going to start snort and RRE, and basically when we start it, it's going to push a set of rules to basically check all the packets that are coming in from the laptop into the relay, and these packets are going to be deep inspected by RRE. And basically, if we repeat the attack again, and we try to send the select before operate packet, we're going to see that snort alerted that we have an unauthorized object from this IP address, which is the IP address of the laptop, and basically it decided it's going to block access for the laptop into the network, and it pushed the entry into floodlight. By blocking the access of the laptop into the network, it didn't allow the disconnect packet to go through, and thus the light is still on. And so finally, this was a joint work leveraging SEL's Watchdog. RRE uses OpenFlow for dynamic responses. In the future, we plan to actually port RRE into the final commercial product, Watchdog. We plan to extend OpenFlow to basically get more application layer kind of policies such as RBAC, which is role-based access control. And finally, want to support more kinds of alerts such as Pro Alerts or the generic IBM MEF. Thank you.